Okay, so I'm going to open my camera just for today and just for now so that everybody can see me, so that you can know who you're talking to. And then I'm gonna switch it off as soon as I just finish introducing myself, and then we can start with today's session. So I hope you are able to see me. Let me see how, because I can't see my screen. Yeah, so obviously everyone can see me. So my name is Elizabeth Boy. I will be your facilitator for the course of the sessions that are we have scheduled for you. I'm not going to bore you with telling you who I am, where I come from, what I eat, but I'm just here to support you because this is our first session, and the purpose of today's session, or the upcoming sessions as well, is to support you and get you ready to go and write the exam, especially those who are doing QMI, BNU, and DSC1630. I might not be 100% sure there, but I think those are the modules that I'm going to support you. So for today's session, I'm going to tell you more in details later on. But for now, this is just the basic thing that you need to know. The reason why you're here, it's because UNISA decided to support you with your modules in terms of giving you the skills or unpacking some of the concepts and making it easier for you to understand your module better. So without wasting any time, let's get to our session. So every week when you come to the session, please make sure that you complete the register, which will be posted in the chat. Is a link. You just click on it and complete the register. The second part is at the end of the session, I will post the evaluation link for every session that you attend. If I forget to give you the register or give you the evaluation link, please let me know so that then I can post it in the chat and then you can complete it. Thank you. Then our sessions, because also I didn't have your exam dates as by the time I developed the session outcomes. I would like us today, before we start with the session, in the chat, or you can unmute to just let me know which areas you're struggling with, which areas that you need more support from. We can rearrange the lessons as well. The other thing is, if you know when you are writing your exams and you can see the dates of the sessions that are scheduled, and you are writing as early as May with your exam, or your exam starts as early as May, especially for your particular module, please let me know so that we can also rearrange and look at how we can support you best. At the moment, this is the schedule as per the sessions that we're going to have going forward, but we're gonna take around about 5 minutes for you to have a discussion so that I can also understand the areas that you are struggling with. For today's session, we are going to keep it at a basic level, covering all the basic numeracy and quantitative literacy skills that you need to know in order for you to excel in this module. So we're gonna take it slow, but keep it at basic level. So we're going to look at different units in your module, depending on which module you are doing. Some of them we'll cover them in detail. Some of them we might go through them because you have gone through your module and you do understand the concepts within your module. So we're just going to brush up those skills, and then so that then we lay the foundation for further units or further skills development as we go along. So like I said, we're going to look at the basic things. So how we apply the laws of operation, looking at how we prioritize in terms of the basic operations by applying or by using the Bodmer's rule. We're going to look at fractions and ratios. I'm not sure if we're going to cover everything in detail today, but there are some couple of things that we can cover, like fractions that we will look at, powers and roots, and maybe we might touch on measurements depending on the time. So we have from now until 8 o'clock, and I hope the 2 hours that we have will be fruitful. Yeah, so before I even get to that, so let's get to my question that I've asked based on what I've just said. So I'm going to go to the chat to look at, please talk to me on the chat, or you can unmute. Let's have a discussion. Which areas, since you have submitted all your assignments and now you are gearing up to go and write your exam, like I promised, I'm going to switch off my camera now so that then we can have that discussion. So for the next 5 to 15 minutes, depending on your interaction. And the other thing that I must also mention is my expectation to supporting you, because I haven't had any engagement with you. I don't have access to your assignments. I only have your study guide. So I rely on you to tell me where can I support you best. Which areas you wrote your assignments, you know the outcome of your assignment. Please let me know where I can support you best. I'm gonna check the chat now. I see Ndima has posted the register. So who wants to go first? I also don't like it that I'm the only person who's going to be talking from now until 8 o'clock. I like us to engage, to talk to one another, because we're going to do some activities as well. So I'm looking at the chat. There is nothing. Are there specific areas that you are struggling with? I'm not sure if you guys can hear me or your mics are muted. Or you are unable to talk to me or anything like that, but the chat function should be available for you to type something. Please, please, I would appreciate that. Pretty please. Nothing. How am I going to support you guys if I don't know what you're struggling with? Oh, thank you, Imran. Linear equations and graphing. Hey, thank you, Imran. Anything else? Because if you're not talking to me as well, I'm going to follow my schedule the way it is, and it might be that I'm going to be repeating the same thing that you already know, and I don't want to waste our 2 hours together on a weekly basis. Please talk to me. Even if you are sure that your meds is killing you, I just want to hear from you guys. Please. It's gonna be a long 2 hours. Okay, since you guys you don't want to talk to me or engage with me. Oh, Stevens, you want to say something? Oh no. Okay. All right. So I'm going to follow the schedule as we have it and go through the sessions. So since the linear systems and equations was mentioned, so I'm going to bump it up. So next week on the 29th, Instead of doing making sense of data handling, we're going to talk about the linear systems, because that's what you guys say you are struggling with, and then the rest of the sessions will follow. So I'm going to change it up so that then the person who's struggling with linear system, because they raised that as an issue, to get the support that they need, so that then they don't have to come week in, week out. If they only want to learn about linear systems, then they can attend that session, and then that's it. Then they can go and prepare. The other thing that I also need to mention is, by now, you should all have your financial calculator to use in your exam. If you don't have it, please make sure that you go and buy that, because by the time you go and do your financial calculation or your financial math, your simple interest, compound interest, amortization, you really need to have that financial calculator. Some of you also like to use the Casio calculator especially for calculating fractions, the roots, and so on. So you can have two calculators if you want, but the most important one is your financial calculator. So during the course of the sessions, as we go along, we will introduce some ways in which you can use your calculator effectively, including also for today's session as well. I hope you all have your calculators ready. So without wasting more time, I don't have access to my chat as yet now. So I'm going to, chapter 4, measurements. Okay, I think we might cover some of the questions on measurements today. So you are covered in that aspect. So let's begin. So if we need to solve equations or solve maths, the first place where we need to start with is understanding numbers and how to work with those numbers. But just numbers alone will not help you. You need also to know how to work with your basic operations. And what we mean by basic operations, those are your addition, subtraction, multiplication, equal sign, as well as the parenthesis or brackets. You need to know how to work with them. That is the base for you passing or calculating your questions correctly. It's by understanding and learning the basic skills of using basic operations and numbers. So one of the functionality, or one of the areas, or one of the things that I like to use is the BODMAS rule. If you know what BODMAS rule is, then you will know the laws of operations, because BODMAS rule tells you it's an acronym actually, which represent B for bracket. B is for bracket. Oh, sorry, my pen is not writing. I thought my pen, okay, so I'm going to have a problem because my pen is not responding to my slides. So B is for bracket, O is for operation, is for exponents, powers. In the olden days, we used to call it an off, but it's not really an off. It's about exponents and powers. And D is for division, M multiplication, A addition, S subtraction. That's your BODMAS rule. What does it mean? It means if you are solving a mathematical function or a equation, and that equation has brackets, it means you have to resolve what's inside the bracket first before you do anything else. O which stands for exponent. It means if the equation or the function has exponents or powers, then you need to resolve them first before you can do the other basic operations. For example, division, multiplication, addition, and subtraction. If you have division and multiplication, you have to resolve them before you can do anything about addition and subtraction. Now, where we have the laws of operation, it's when you need to remember when you have division and multiplication in the same function and or in the same equation, you have to move from left to right. So it means brackets before exponents, division, multiplication, addition, and subtraction, division and multiplication before addition and subtraction. If I have division and multiplication, I move from left to right. If I have addition and subtraction, same rule applies, the same as division and multiplication. Addition and subtraction have the same priority, so we move from left to right. If I have a division and an addition, I first have to do a division before I can do the addition of the units or the numbers or the variables. So division and multiplication comes before addition and subtraction. The reason why I'm saying all this and I'm pointing it again and again is so that you understand this. Because sometimes we make this kind of mistakes because we say, but Bodmer's rule says division, multiplication, addition, and subtraction, therefore division comes before multiplication. So if your equation has multiplication, division, you can just move from left to right. So you will multiply, divide. If your function or your equation has division, addition, and subtraction, you start first with division, then you go addition and subtraction. If it's division, subtraction, addition, then you move from division, subtraction, and addition, because addition and subtraction have the same priorities. We move from left to right. So based on that and based on everything that I have just said, I hope the chat is going to be flying with answers. Let's start solving number 1. Solve the following expression. Here you are given 36 multiplied by 8, subtract 34, multiply by 8. What is the answer? I want to see the answer in the chat. Let's go. Are we winning? Just put the answer that you get. Don't worry about right or wrong answer. It's still the beginning. We're here to support you. We're here to help you get it right. For A, let's have the answers in the chat. I see already someone posted is 16. What about the others? Let's go. Come on, guys. Let me see if you guys are working in the background, because the only way for me to know if you guys are working is by you sharing your answers. Yes. Okay. I got 62. The answer is 16. Yes. Yes. Let's see. Others? Anyone who got a different answer? Post. Let's go. Let's go. Oh, 16. Hey. Okay. So, since my pen doesn't want to write, I don't know how I'm going to do this. Let me see if I can activate the pen. Sorry. Every time I click, it moves around. I'm so sorry for this. I apologize. My pen is not activating. Please. Just give me a second. Even my, this is so weird. Just give me a second because I won't be able to continue if I can't. If I'm unable to write on the screen. Okay, there I'm able to write. Let's see if it can activate. We're back. We are back. Okay. I don't know why it was acting like that. So using the BODMAS, we need to first look at the operations. So we've got multiplication, subtraction, and multiplication. And BODMAS rule says multiplication before addition and subtraction. So it means we're going to first solve that and solve that side. So 36 times 8 is 36 times 8 is 288 minus 34. 34 times 8, which is 272. And 288 minus 272 equals 16. So we are all happy. Now let's go and do number B. Let's have the answers on the chat as well. So let's see if we can answer B. Are we winning? Let's go. Let's go.
That's one I remember. In this class. Do you remember? Do you understand?
Let's see the answers on the chat. Let's see. Yes, I have 441, 387, 441, 441, 288, 441, 126. Yo, others, are we all covered? 441, 441. Okay. I see the majority say 441. Okay, good. You posted multiple times, so you're confusing me. But anyway, so I just want to see that everyone has posted. Logan, I see you did went back and correct. Okay. So I'm gonna assume that, my mistake, it is 441. Oh yeah. Anyone who also wants to go back and correct? Say 2. Oh yeah. Say 2 also went three times. You see, that is the smallest mistake you make when you do your calculations without paying attention or without using Botman's rule or laws of operation can cost you a lot. So you need to pay attention to little things. So every time you look at the functions, every time you look at equations, ask yourself, Botman's rule, what operations do I have? How do I resolve this? Remember, brackets before addition and subtraction and multiplication before addition and so on. And you can also use your calculator to answer the question. The mistake we make when we answer questions, sometimes we don't use the brackets. So please, if you use a calculator, you can type it as you see it on the screen or on your paper or on your exam paper. Anyway, you write it the same way as you see it. Your calculator will give you the answer. If you're calculating it manually, then remember to always use BODMAS. So how do we get this? For those who didn't get it right, the first thing, we need to go back to our BODMAS. BODMAS says brackets first. So we've got 7 multiplied by open bracket, 6 multiplied by open bracket, 5 plus 4 close bracket, plus 3 multiplied by open bracket, 2 plus 1 close bracket, close bracket. Now, you can also remove all the multiplications that are closer to the bracket. So the same equation can be written as 7 times 6 times 5 plus 4 plus 3 times 2 plus 1 and close bracket. You can write it like this because the multiplication, it says 7 multiplied by everything in the bracket. So a number before a bracket means that number multiplied by whatever is inside the bracket. Now, since I've rewritten it like this, I can go back and look at my BODMAS rule. Still brackets first. So I need to go and resolve the brackets that are inside the bracket because I know that this big bracket and the big bracket at the end, they correspond. So I'm going to resolve the brackets inside first. So what we do is 7 times 6 times 5 plus 4 is 9. So what I can do is I can remove the bracket, so I don't have to write it. I can put a multiply there. And then I can continue and say plus 3 times, because 3 multiplying with everything that is inside the bracket. Inside the bracket is 2 plus 1, which is 3. And then I close the bracket because we have that open bracket or closed bracket there at the end. Now, I go back and I look at inside the bracket. I have multiplication, addition, and multiplication. What does that mean? Multiplication comes before addition. So it means I need to multiply first. So 7 times 6 times 9 is 54. Plus 3 times 3 is 9. Now, bracket, multiplication. So it's bracket, so I must resolve whatever is inside the bracket first. So what is inside the bracket is 7 times, so I can remove the bracket and just put the multiplication. 7 times 54 plus 9 is 9, 3, 6, is 63. 7 times 63, 21. Sorry, I'm doing this manually. 7 times 3 is 21. 7 times 6 is 3, then it's 44. So the answer is 400 and it's 41. 42 carry 2. Yes, it's 44. So the answer is 441. Happiness, are we good? Are we happy? Let's see, thumbs up or comment. We happy, we good. So say 2 still got 63. Say 2, are we good? Thumbs up, yay, 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 yay. Popping, 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 yes. That's it. That's how you do maths. Okay, so that is the basic thing that you need to learn in order for you to get everything right in, especially even when we go and do linear functions, equation, linear inequalities, all of those, they also rely on Bodmer's rules. So everything you do, even with the fractions, you still need to learn and know the basic operations laws, that multiplication and division have the same priority. We work from left to right. Addition and subtraction have the same priority. We work from left to right. Okay, so let's move on to the next section. So since today we're taking it slow, don't worry. I'm not going to stress you a lot. We also have what we call powers. Remember from the Bodmers, we spoke about exponents or powers. We interchange powers and exponents. So what is exponents and powers? So exponents are actually the mathematical function that can be written with a base and a power. So you have a base and a power. A base is raised to a power. That is what a power means. And that is what an exponent is. So it's one and the same thing. They are used interchangeably. So what does that mean? A power means any number or any value that you see on a base can be multiplied X amount of time by that power. So you multiply that base by itself X amount of powers. So let's say for number, I'm going to do number 2. Let me do number 1, and then you do number B. So with powers, here are the following. So when you see a 2 to the power, 2 raised to the power of 3, it means, or it's the same as that number multiplying by itself, your 3 times. Because I'm saying 3, I'm writing 3. My brain, mind me, because we are at the end of the day. It means that number raised or that number multiplying by itself that many times. That's what a power means. And that doesn't end there, because that is equals to 2 times 2 times 2, which is equals to 2 times 2 is 4. 4 times 2 is 8. On your calculators, those who have Casio or financial calculators, it doesn't matter. You will have powers. Usually, they are either written as x to the power of y or x to the power of 2. Anything that is written x to the power of 2 is what we call a power of 2, which is the power of 2, is the square root. Or not the square root, it's an x to the power of 2. You can use that function to calculate it on your calculator. If it's to the power of 3, 4, 10, 100, you can use x to the power of y function to calculate it. And it's easy, because if I need to calculate 2 to the power of 3, all what you need to do is say 2 and then press the x to the power of y to raise it to the power, and then you put 3 and then you press equal sign. That is the other thing that we didn't speak about, equal sign. It's very important. So you say 2 and then you press the button that has x to the power of y, and then you press the equal sign, and the answer will give you 8. Those who are using Casio calculators, usually I think it is x, it's the function that written x to the power of a bracket at the top, because some of the Casio functionalities, they are in brackets. If it's a placeholder, it's something that holds the value. So you can press that functionality, it will still work the same. So for those who are using a Casio calculator, yours, you just press this functionality and it will put the 2 squares on your calculator. So you will have a square and a square, and you just put the value in there and the value at the top. That's how you use your calculator, your Casio calculators. Okay, so what about, I'm not going to go and ask you to calculate 4 to the power of 2. It's easy to calculate. I've already showed you how to calculate it. But some of you are doing things like differentiation, and you are going to be working on solving equation that has to the power of a negative number and so on. You need to know how to use the power of a negative value. So when you have a power to a negative number, so here is the thing that I always say, you can change this to a fractional half. Or a fraction. So what do we mean by that? A negative is the same as 1 over. A negative is the same as 1 over. And then the number that you see after the negative will go to the power, right? I hope you understand. This negative number is the same as 1 over. You can write it as such. And everything else will be in the denominator, which will be to the power of 1. You keep everything as is. So it means 3 to the power of a negative 1 is the same as 1 over 3. What about 3 to the power of negative 5? So 3 to the power of negative 5 It doesn't change anything. The same way as I did it, 3 to the power of -1 was 1 over 3 to the power of 1, because it's raised to the power of a -1. So it will be 3 to the power of 1. So a 3 to the power of a -5 will also be the same as -1 over, it's a reciprocal, 3 to the power of 5. And we know that 3 to the power of 5 is the same as 1 over 3 multiplied by itself 5 times. So it's 3 to the power of 5, which is equals to 243. So you always need to remember that. When you see any number to the power of a negative, do not panic. You can just resolve it by making the negative number a 1 over. You want to practice more? I can give you a practice, but it will be difficult for you to post it on the chat. But I can make it easier. So, what is 2 to the power of -2? 2 to the power of -2. You can write it in words if you want. You can say it is equals to, like I said, the first one is 1 over 3. You can say it like that. So when you get to the answer, write it in the chat. So 1 over 3, or is it 1 over 243? So you just write the over there, and then the numbers there. So let's see. 2 to the power of -2. It should be easy and quick and simple and straightforward. Let's see. 1 over 4, 1 over 4. Yes, 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 yes. See how easy it is. Easy, simple. And you can do this with any number. It doesn't have to be as easy or simple as this. Right. So because we're doing basic things today, we're touching up. I'm making you feel at home. If you are stuck, I want to make sure that you get unstuck, so that when we go to the more detailed and dense content, we don't have to explain the basic things. So now, there we were talking about powers and exponents on their own. What happens when we start adding the basic operations to the mix? Then everything changes, because now we need to always remember. We need to always remember that we sometimes work with integers and whole numbers and negative numbers and so on, real numbers and so on. So the laws of exponents also, you need to know the rules that governs the exponents, because the minute you start applying your basic operations, everything changes. So let A and B in this instance will be our positive numbers, which means these are going to be our bases. You remember, in terms of powers, our base to the raised to the power, right? A and B are going to be our base, whereas X and Y are going to be our real numbers. These are the numbers that we're going to use in the power. In terms of the rules, if we have the following, so I'm going to start from left to right because they are all different. So all of them are different rules that you need to remember. The first rule states that if you have multiplication of two exponents with the same base, you add the powers. That's what it says. If we are multiplying two exponents with the same base, they have to be the same base. It cannot be A and B. They all have to be, the basis has to be A and A, B and B. It cannot be A and B. So if I have the same base and I'm multiplying the two exponents, I just need to add the powers. 2 to the power of 2 times 2 to the power 4. That's what the rule says. Easy for cheesy. We just need to say 2 plus 4. I think my red color is not that visible. I hope you can see it. I should have made the background black. And the answer will be 2 to the power of 6. You must always remember when we're working in mathematics or with numeracy, quantitative, you must always resolve your answers to the simplest form. A 2 to the power of 6, depending on when you are looking at the options on your answer sheet, please pay attention because most of the time you're writing multiple choice questions. If the answer is to the lowest form, you need to resolve it. 2 to the power of 6 is not the lowest form. But on your options, on your exam paper, if they have, this is an option, then you can answer it in that manner. But with math, you need to always resolve your answers to the lowest. So 2 to the power of 6 is an exponent. So we need to resolve it to the lowest form, which is 2 to the power of 6, which is equal to 64, because it's 2 times 2 times 2 times 2 times 2 times 2. 2 times itself 6 times, which is equals to 64. That's the first law. The second law says, if I have to find the quotient, or if I am dividing two powers with the same base, always remember, same base, two powers with the same base, I just need to subtract the powers. So what does that mean? If I have 3 to the power of 4, divide by 3 to the power of 2, this rule says all I just need to do is put it to the base of 3 because they've got the same base and subtract the powers. We subtract with your numerator. So your first is your numerator minus your denominator. I know that I'm raising some concepts that we still need to cover in terms of fractions, but that is how you do it. You say 4 subtract 2, which is the number at the top minus the number at the bottom. And that is 3 to the power of 4 minus 2, which is equals to 3 to the power of 2. Easy. Which is equals to 3 times 3, which is 9. Easy. I hope you do understand now. If I have the same bases and I'm dividing them, they both are dividing each other, but they've got the same base, I just need to subtract the powers. Okay, easy, straightforward. Now, if I've got multiplication of the powers, so what does that mean? If I have b to the power of x into bracket to the power of x, therefore it means the powers are multiplying each other. That is what it means. 4 to the power of 2 to the power of 3 is the same as 4 to the power of 2 times 3, which is equals to 4 to the power of 6 and 4 to the power of 6, which means it's 4 multiplying by itself 6 times, which is equals to 4,096. 4,096. I can't see what is happening on the chat. If you are lost or I'm going too fast, let me know. Or you're gonna be left behind if you don't ask. The next one, it says, if I've got two bases and multiplying by or raised to the power, the two bases are multiplying and they are raised to the power because of the bracket. So it means if I have A times B to the power of a number, now you need to pay attention to this because this is inside the bracket. So it's open bracket, close bracket, raised to the power. What you can do, you can still say A multiplied by B, raise it to the number, or because it's A times B, both of them can be raised to the power. So it's Now, here is where it gets complicated. When you work with numbers, remember now, we said but must say powers first, addition and subtraction and division and multiplication, and we said brackets before exponent. That's what we said, right? However, in this scenario, it's not brackets before exponents because it's exponents. The exponents are raising the bracket. I'm not sure if you do understand this. In this instance, the exponent creates, because if we didn't put the brackets, then it would have been A times B to the power of X. Now, in this scenario, think about it in this way. So if I have, it's not, here is the thing, because you're going to have like numbers like 39 to the power of X, right? And you're going to have a number 3 times 9 to the power of X. The scenario that we're talking about here is not the 39 to the power of X, because 39 is a number on its own. So you cannot say it's 3 times 9. We read it as 39, unless there is a dot in between, but also pay close attention, because in mathematics, a dot can be a comma. But in this instance, a dot means multiplication in maths, right? So if you have 3.9, because if it's a 3.9, which is different, a 3.9, that's when it is 3.9. It's not 3.9. A 3.9, it means 3 multiplied by 9. So that's how you write numbers. And especially now, if you are in economics, you need to know and remember this. And also in terms of quantitative maths, you always need to remember that a decimal or a point in this instance, when we are doing the early stages, not in some financial maths, because in financial maths, it might work differently, because we might use a point instead of a decimal. So it still applies. So in this instance, this is 3.9 is the same as 3 multiplied by 9, or 3 with an actual multiplication. That's what it means. So what does that mean? It means in terms of this rule that we have, sorry, I don't know, I'm trying to erase. And okay, in terms of the rule that we have here, so if we say 3 multiplied by 9 to the power of 2, this is what we mean. We say it's the same as 3 to the power of 2 multiplied by 9 to the power of 2. Because in maths, you can, but again, in maths, there are many ways to skin a cat. You can use that same concept. 3 times 9 to the power 2. It's, what is 9 to the power of 2 is 81. So it will be 9 times 81. 9 times 81 is equals to 729. Okay, so That is if, let's say, for example, if they were asking you, show us the steps, because you are writing multiple choice questions as well. Your calculator is your friend sometimes. You can also take a shortcut because there are always shortcuts, especially when it comes to multiplications, right? So, because we know that with BODMAS says everything in the brackets before exponent. So you can still say 3 times 9. What is 3 times 9? 3 times 9 is equals to 27. And raise 27 to the power of 2. So it means it's 27 times 27 to the power of 2. It will still give you 729 because BODMAS rule still applies. The last one, unless if there is a comment in the chat, something like that. The last one says, if you have a fraction to the power of an exponent, same as when you have a multiplication with inside the bracket with an exponent, you still going to multiply with the powers. So if I have 1 over 2, which is the easiest way of doing this question, is the same as 1 to the power of 2 divided by 2 to the power of 2, which is 1 over 4. It's easy. Or what about if I have, let's make it more complex. 16 divided by 3, everything to the power of 2. So it's still the same. It will be 16 to the power of 2 divided by 3 to the power of 2, and you can still solve the equation. 16 to the power of 2 will be a very big number. I don't know why did I say that, which is 256 divided by 9. So what is 256 divided by 9? It's 28.44, a number. 8.4444, depending on what the decimals are. If they say everything rounded off to 4 decimals, you just round it off to 4 decimals. Okay, any questions? I'm gonna give you 2 minutes to ask any question, to raise anything you want to raise. Let's see the chat. What are you saying in the chat? Nothing. There are people in the lobbies. I'm sorry. Let me let them in. I'm going to give you that 2 minutes to think about a question. Lele 2, please mute yourself. Thank you. Okay. Are there any questions for me up to so far? We spent 1 hour on 2 things. You guys, we're still gonna get to, I don't think we're gonna get to the measurement. And I know that measurement is something that you guys raised. So I will have to, I'm gonna send a new updated schedule to accommodate all the burning issues that you have. So I'm also going to still give you time. If you still know there are a couple of things that you're struggling with after you wrote your assignment 1, assignment 2, remember this is in preparation for you to go write your exam. Think about with the areas that you are struggling with that you need reinforcement. And also, if you do have any documentation that you want to share with me, I'll give you my email address that you can also send me any documentation to help me prepare so that we come here and use the real questions that you have or that you are struggling with. Don't mind sharing with me anything that will help me prepare to get to make it easier for us to interact week in, week out, so that then I can use the exact questions that you are struggling with as examples in class to simplify things for you. Okay, so I see there is nothing in the chat, so we're going to move on to the next. Before I move, I still have 2 more minutes. I'm gonna give you back that the 2 more minutes. Think about the areas that you are struggling with up to now and post it on the chat. I'm still going back with round number 2. Okay, so there is nothing, and I still have 1 more minute. So in the absence of any topic or area that you guys are struggling with, we're going to continue where we left off. Now we're moving on to the next other section, which is roots. Roots and powers are like cousins, cousin and sister. It's like 609, they are fun. You know those things. They are like same WhatsApp groups, things like that. So you can always use them interchangeably because they are cousins. So let's get to the roots. So what are the roots? So like I said, roots and powers are like cousins. So the root is the opposite of what the power is. So with the power, we say, what is that number that when we multiply by itself so many times, it gives us this? With the root, we say, because the roots, we can determine them by the caravan or the house or whatever you can call it. Those from Durban, you can call it that thing that people go on. I don't know what you call it. Where someone is in front and they go with someone at the back. People who knows that. I don't know what they call them. Those people. So what a root is. A root, we look at the number that is inside the house or the caravan and we say, there will be also a number in front of the caravan. And with that, we say, what is that number that when we multiply that number by itself so many times based on that number in front of the caravan gives us the number that is inside the caravan? I'm complicating your life, I know. I'm trying to simplify it. So a root, like for example, the caravan, without a number in front, this caravan always has a 2 in front. Whether we write a 2 or we don't write a 2, it doesn't matter. The same applies. Maybe I must go back 1 step back because I didn't go into details in terms of powers as well. In terms of powers, any number, let's say it's 1, it is to the power of 1. Any number, 100 to the power of 1, it's 100. We can write it as such. So any number to the power of 1, it is that number. right? So you can either write to the power of 1, especially those who are doing differentiation, or those, I think QMI and DSC, you do have a component of differentiation. So you need to always remember that. You need to always remember that any number without a power is raised to the power of 1. We don't have to write the power of 1 on all the natural numbers, but always remember that it is there. There is a power of 1. So that is the same with the root. So also, any number 1 to the power of 0 is 0. Oh, no, it's not 0, it's 1. I'm teaching you maths. It's 1. 100 to the power of 0 is 1. 20 to the power of 0 is 1. But 0 to the power of 0, it will always be 0. Any number to the power of 0 is equals to 1. Okay, we've covered that. The same applies to the root. The root, if you don't see a number in front of the caravan, know that it is to the power, is the root. And what that is called in terms of the full name, we call this a square root. Then you will have the ones where there is a 3 in front, it's called a cube root, a quadro root, all of those. So as long as you see a number in front, you just say, what will be the number that when I multiply that number by itself 3 times, it will give me the value x. That's what the root is. If I have, what does this mean? What is that number that when I multiply that number by itself 2 times, it gives me 4? That's what a root is. And that number will be 2, because 2 times 2 gives me 4. And this is, if I say, this is 8, and I say, what is that number that when I multiply that number by itself 3 times, I will get an 8? And that is 2. Because 2 times 2 times 2 gives me the number in the caravan. There are also some exceptions to these things. Like, if I have a power to a fraction, which is something that we didn't talk about. Before I get to that one, let's answer this question, because I just mentioned some of the basic things that you need to know about the roots. What is that number that when I multiply that number by itself 2 times, it gives me a 9? You can answer both of them at the same time. It's this and that, right? What is that number that when I multiply that number by itself 2 times? Because if you remember, in front of the root, if invisible, means there is a 2. What is that number that when I multiply it by itself 2 times, it will give me 25? Give me the answers. Let's see. Let's light up the chat. Three and five. Yes. 3 and 5. Yes. 4 and 2. 42. Unless, oh, Imran, you are way too fast. You moving too fast. We still on number A. 3 and 5. 3 and 5. Okay, so that means you guys, you do understand this. So easy, for sure easy. Now, what I was talking about earlier was the following, because with the root and the power, That's why I said they are almost like cousins. If I have 9 to the power of a half, I can write it as, remember when we had the negative number, we said it was 1 over. Now you have 9 to the power of a fraction. If you have any number to a power of a fraction, you can write it as a root. We can change it and write it as a root because 1 over becomes your caravan. I love my job and I'm passionate about what I do. 1 over, in terms of that fraction, 1 over, it is what we call a caravan. So if I can change this, I'll write 1 over as my caravan. What will go in front of my caravan will be the power, which is 2. What will go under my caravan will be 9. That's why I'm saying 6, no 9, they are fun. Whether you put it this way or that way, they can always be almost the same. So a 9 to the power of a fraction half can be written as the root or the square root of 9. Because 1 over is my caravan, if you always remember, especially those in differentiation, we're going to get to this kind of questions and you are going to scratch your head and think, hey, what's happening here? How do I solve this? How do I? No, don't worry. If you have a root, a 9, this root, we could write it as 9 to the power of a half because in front of the root, there is a 2 there, there is a 2 there, and 25 can be written as 25 1 over 2. So you can interchange to the power or to the root. What about when it is 8 to the power of 3? Same, nothing changes. 1 over is my caravan. So I'm still going to put my caravan on. And that would be a 3. And underneath there will be an 8. Oh, same. Or you can use your calculator to answer the question. There's nothing wrong. They will still give you the same answer. Whether you answer your question by using 8, 1 over 3, or you use the cube root of 8, the answer will still be equals to 2. So that is the other thing. Okay, so now let's get to more difficult things. Let's answer B. Remember, we're bringing everything now back together. So B, 3 to the power of 2 times 7 minus the square root of 9 times 8 plus the square root there, 2 to the power of 2 divided by 4 multiplied by 3. You can do this step by step, or you can put it in your calculator and get the answer. So BODMAS rule must apply if you're calculating manually. Let's see the chat. let's go. Answers in the chat. Answers in the chat. Let's see. Let's go, let's go, let's go. 42, 42, 42, 42, 42. So it means everyone knows the answer. None of the answers are different to, I hope you're not copying what Imran has posted before as your own answer, because then you are shooting yourself in the foot if you do that. So let's help those who didn't know how to answer this, because I can see there are still a couple of people who are still trying and they are not posting. So it means maybe probably they are stuck. So BODMAS rule, brackets, there are no brackets. Exponents, yay, we start with the exponents. 3 to the power of 2 is 9, multiply by minus. Remember, exponents or other like roots and all that. So we can also use the roots as part of it, because roots and exponents are from the same family. They are cousins. So they've got same blood, even though they are not from the same mother, but they are related. So square root of 9 is 3. Multiply by 8 plus 4. Divide by 4. Multiply by 3. So we have removed everything. So BODMAS. Division and multiplication have the same priority, and they come before addition and subtraction. So what do? We multiply. There is something that I'm missing. I'm missing 7. So we multiply and divide before we go back and subtract and do all the other things. Okay? So let's do the multiplication. Since multiplication and division have the same priority, we work from left to right. So we're working. 9 times 7 is 63. Minus 3 times 8, 24. Plus, now we've got a division and multiplication. So we working from left to right. Doesn't matter. So 4 divided by 4 is 1. Multiply by 3 is 3. 4 divided by 4 is 1. 1 multiplied by 3 is 3. So we have 63 minus 24 plus 3. The answer is, seen from the chat, it's 42. I hope from now on, from today, you now know how to solve your maths problems in your module. Okay, moving to the last part, because we only have less than an hour to do the next, which is the fractions. So the next time I must rearrange and redo some of this so that we can cover linear functions and measurements for others. Okay. Fractions. So with fractions, I want to spend more time with fractions because they are very important. There are many ways of doing fractions as well, but we will touch the basic things. So a fraction is part of a whole. It represents a whole. So if I have pizza, when I take away slices of a pizza, I'm taking away from a part of a whole. Those slices, I can count how many are left, or I can count how many are eaten. So now, depending on that whole, if the whole has 8 pizza slices, therefore the 8 pizza slices are what we call the denominator, which is the number below. The number that I'm looking for, or the number that I need to seek, is left or it's been removed. It's going to be a numerator, will be the number at the top. If I've got 8 slices and none of the slices are missing, then I've got 8 over 8. If I take away 1, and I want to know how many slices are remaining out of the 8, then I've got 7 over 8, which means it's a fraction. We now talk about numerators and denominators. We need to know how to work with the fractions. So how do we do that? So there are different types of fractions as well. So there is no one fraction, there are different forms. So what are those? There is one where we call an improper fraction. So a proper fraction, let's start with the usual one. The proper fraction is when you have a smaller numerator and a bigger denominator. So your numerator, which is the number at the top, is bigger than the number at the, or it's smaller than the number at the bottom. Then you have the improper fraction, like a bigger number at the top and a smaller number at the bottom. That's what we call an improper fraction, 7 over 4. Then we also have what we call a mixed fraction, where we have a whole number and a fraction. And that fraction can be improper fraction or proper fraction. But always remember, an improper fraction has a lowest form, and the lowest form of an improper fraction is a mixed fraction. And sometimes it's not easy to work with a mixed fraction. We need to convert mixed fraction into improper fractions to use them. Unless if you're using a Casio calculator, because the functionality is there to allow you to do improper fractions or work with improper fractions. So what are mixed fractions? Whole number and a proper fraction. So it means an improper fraction is not to a lowest form. The lowest form of an improper fraction is a mixed fraction. What do we mean? If you have an improper fraction, you cannot leave it as is as an answer. You need to say 4 goes how many times into 7? It goes 1 time. And the remainder will be 4 times 1 is 4. 7 subtract 4, which gives you 3 over 4. That's what you will have. And you can work from a mixed fraction to an improper fraction. Oh, to get from there, you just say 4 multiplied by 1 is 4 plus 3 is 7. 4 multiply, so this side you multiply and you add. So you say 4 multiplied by 1 plus 3 will be 7 over 4. The denominator stays. But now let's go and look at how do we work with these fractions. So same applies with the basic operations. Addition and subtraction, because they are related, they are siblings. We always work with them the same way. So how do we do this? If you have addition and subtraction, the first thing you need to look for is the common denominator. Do they have the common denominator? If they do have the same common denominator, it makes life easier, because all what we need to do is subtract or add the numerator. So it means we keep the denominator because it's the same, and we just subtract the numerator. So we'll say 2 divided by 4 minus 1 over 4 is the same as 2 minus 1 divided by 4, which will be 1 over 4, because they've got the same common denominator. What about when they do not have the same denominator? If they do not have the same denominator, we need to find the common denominator. You can either use the LCM or the multiples, whichever the functionality or the way you remember how to find the common denominator, you can use your Casio calculator. So here we're talking about if we want to calculate these things manually, let's learn how do we do that. We need to find the common denominator. And how do we do that? We say, what are those numbers that 5 and 10 can divide into and not leave any remainder? 5 can go into 10, 10 can go into 5. So the common denominator between 5 and 10 is 10. So that will be our denominator. And how then do we solve this? We say 5 goes how many times into our denominator? 10. Just ignore this 12 there. Those things that are popping up is the number of slides. We say 5 goes how many times into 10? It goes 2 times. 2 times 2, because there is the numerator at the top. So we say 5 goes how many times into 10? It goes 2 times. And we multiply that with the numerator, which is 2. Plus, it keeps the same sign. 10 goes how many times into 10? It goes 1 time. And we multiply with the numerator of 1. And the answer will be 2 times 2 is 4. Plus 1 times 1 is 1, which is 5 over 10. Right. That is not the lowest form of this fraction. Always remember, we need to simplify everything to its lowest form. 5 and 10 can divide into each other, or they can be simplified further. 5 goes how many times into 5? It goes 1 time. It goes how many times into 10? It goes 2 times. So the answer will be 1 divided by 2. You can still find the same answer by using your Casio calculator. Those who have the Casio calculator, you do have the functionality that looks like this, especially for those who didn't do maths or maths literacy at school. You will know this, or those who did maths the same time that I did maths when the calculators were not allowed. So these days, calculators are allowed. So you do have this kind of a function. You can use it for your fractions. Nobody's gonna know. All right. And if you want to use the mixed fraction functionality on top of this function, there is an orange thingy, letters, and sometimes it's written like this also. It's written in orange. So you first need to press Shift button and then press this for mixed fraction. I'm just giving you tips right now as we go along, because I'm going to do these things manually. I don't have an online Casio calculator to show you how it works. I'm hoping that you will know how to use your functionalities. If you don't know how to use it, please, you can schedule time with me separately. We can WhatsApp each other. We can do a quick online thing, and I can show you how to use your calculator effectively. But I need to know if people don't know how to use their calculators as well. Okay. So that is addition and subtraction. Now, what happens when we have mixed fraction and proper fractions and addition and subtraction? Same. We first need to resolve the mixed fraction. So with the Casio calculator, you will be done within a click and 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 a click. I mean, then you get the answer. If we have to do this manually, we convert the mixed fraction into a proper fraction. 2 times 1 is 2, plus 1 is 3 over 2, minus 1 over 6, plus 2 over 3. Addition and subtraction have the same priorities. We move from left to right. So it means all of them, we can treat them the same. So we need to find the common denominator. What is that number that 2, 6, and 3 can divide into and not leave a remainder? And that number is 6. Because 2 can go into 6, and 6 can go into itself, and 3 can go into 6, and not leave a remainder, because the answer will be a whole number. How do we then do that? We say 2 goes how many times into 6? It goes 3 times. 3 times 3 6 goes how many times into 6? It goes 1 time, 1 times 1. And 3 goes how many times into 6? It goes 2 times, 2 times 2. And we solve. 3 times 3 is 9, minus 1 times 1 is 1. And 2 times 2 is 4. 9 minus 1 plus 4 is equals to 12 divided by 6. Now we've got an improper fraction. So we come from a mixed fraction and proper fraction to the answer that we now have in front of us are improper fractions. So it's not the lowest form. We can still go further. 6 goes how many times into 12? It goes 2 times. And that's the answer. There is no remainder because 6 can divide into 12. And that will be the answer. If we had 5 into 12, so if the answer here was 12 divided by 5, then there would have been a remainder because we would have said 5 goes how many times into 12? It goes 2 times, and the remainder is 2 over 5 because it's 5 times 2 is 10. 10 plus 2 is 12. So here, 6 goes how many times into 12? It goes 2 times. The remainder is, there's no remainder. So it squares up. Right. Next, so that we can do more exercise. There is your question. Let's see if you can answer this. We're only going to do one exercise for the addition and subtraction, and then we move into multiplication and division. So let's see. Simplify the following as far as possible. That is what you need to do. They all have, you need to find, they don't have the same denominator. So because they don't have the same denominator, you need to find the common denominator. What will be that number that all of them can divide into and not leave a remainder? Otherwise, you can punch it through your calculator and get the answer. Are we winning? Are we winning? Let's check. Are we winning? Uh, 2/5. 2/5. I'm not sure. So version it was answering something else. Okay, I see Nositelo and Imran have responded. The others, where are we? How are we? Right or wrong? Right or wrong? Let's see. We're gonna correct it. Don't worry. You will also go and see where you made a mistake. Let's see.
After ugqibile uzojonga eqale yavela kuzo zombini. Hayi kukho abantu abayi-20. Hayi abantu abafuna ungena ii-classes.
Melissa Matruos, you can give us the answer. Go back to my 20. They don't know the answer. You haven't responded as well. Can you please explain again what is happening? Lavin, I'm not sure you want me to explain the question or to explain the fractions. Maybe if you can clarify. Sibulel, 12 and 20, there are numbers that can go into those numbers. Lunam, 2 and 4, they can divide each other. So it means also you need to make sure that things can be simplified to the lowest form. Simplify it as far as possible. Not that I'm saying your answers are correct, but I'm just giving you a hint in terms of how you answer your questions. Yes, you say 2. Yes. Lavin, I'm still waiting. Maybe you are still typing. You can unmute and talk to me while people are still writing their answers. 2/5. Similarly, even you are hiding yourself. Oh gosh, you should have a celebratory thingamabob. I don't know what you call it. That thing where you celebrate, don't hide your face, because here we don't worry about that. The fraction, please. Where should I go check it out in the study guide? Which module are you doing? That's the other thing. Remember also, you at some point, whether you're doing DSC or you're doing QMI and so on, at some point you're going to work with fractions, because when you are solving the linear functions or you're calculating those profitabilities and all those things, you are going to end up to have to calculate fractions. QMI, I think it's study unit 1. It's the beginning things. It's everything at the beginning of your study guide. It's things that, not sure if you did BNU or you're doing QMI only. It should be something that you do at the beginning. And if it's not in your study guide, it's something that it's a basic skill that you need to do QMI or any quantitative module. Okay, so let's see. Okay, we've got all the answers, and I can see, let's help those who are not sure about their answers. If we were in a face-to-face class, I would see those who are hiding their face, because they will be hiding their face right now in class. So let's see. So remember, today, anytime from now on, we're getting ready for the exam. So what is the common denominator? What is that number that all of them can go into and not leave a remainder? All of them can go into 20. 4 goes how many times into 20? It goes 5 times. And 5 times 2 minus. 5 goes how many times into 20? It goes 4 times 3 plus 2 goes how many times into 20? It goes 10 times. 10 times 1. And 5 times 2 is 10. 4 times 3 minus 12 plus 10 times 1 is 10 over 20. 10 minus 2 is 10 minus 12 is minus 2 plus 10 is 8 over 20. Now we need to simplify this because we know that there are numbers that can go into 4, into 8, and they can also go into 20, which is 4. 4 can go into 8. It goes into 8 2 times, and it goes into 20 5 times. Hallelujah! It's 5 over 2. Or you could have used your calculator. Those who have a Casio calculators, like I said, you need to have a calculator. So if you're going to the exam, some people prefer to have both calculators or one calculator. Those who are using the financial calculator, which is the most useful calculator, especially when you are going to be doing financial maths, calculating the financial maths problems, yippee, you will have to calculate your things manually like I've done. Those who have a Casio calculator, you will struggle with the financial calculators, the quickness of calculating the financial questions, but you will find it easy to do the linear or the algebraic equations, which are this, like fractions. So it's a win-win situation. So some people prefer to have both calculators. I don't know, when you are writing the exam, do they allow you to have both calculators? I don't think it will be a problem because they will just be there. You can show that you have 2 calculators. And when you are working, the Invigilator app will not be looking at whether you're using a Casio or you're using a financial calculator, a sharp financial calculator. So you can invest in both. If you have a brother or a sister who's in matric or in grade 11, grade 10, 11, and 12, and they have a Casio calculator, borrow that and then spend money on your financial calculator. Okay. If your next door neighbor has someone in grade 10, 12, you can go and borrow and use that. Okay, so let's move on. That would have been option 3. So I'm just going to skip that one and go straight into fractions. I'm going to be quick and easy and fast because when it comes to multiplication and division, we apply similar method but different methods. So in the beginning. So with multiplication, we say there are many ways to skin a cat because the same equation can be answered in 5 multiple ways. The easy way with multiplication is multiplying numerator with numerator, denominator with denominator. That's the easy and quick way, which is just saying 1 times 2 divide by 4 times 6. And that gives you 2 over 4, which we can still simplify it further, which will be equals to 1 over 12 because 2 can divide into 24. It goes into itself 1 time and it goes into 24 12 times. That's the first part. Easy with multiplication. Alternatively, you can simplify by cross dividing. So what do we mean by that? With multiplication, same answer, 3 ways of answering the same thing and getting the same answer. The fourth one is using your Casio calculator and you will still get the same answer. So we simplify by crisscrossing. So we can crisscross numerator and denominator, or we can crisscross diagonally. So at this point, we're crisscrossing the numerator on the other one, the second one, divided by the numerator on the second, on the first one. So 2 can simplify 4. 2 goes 1 time, and into 4 it goes 2 times. And then we apply the same method that we did at the beginning. 1 times 1, because that's what the remainder was. 1 times 1 and 2 times 6. So 1 times 1 divided by 2 times 6. And the answer will be 1/4. That's the other method. The other one, we can simplify numerator and denominator. So how do we do that? You just say 2 goes how many times into 6? It goes 1 time into 2, and it goes 3 times into 6. And the same, numerator times numerator, denominator times denominator. 1 times 1, 4 times 3, which is 1/2. That's multiplication. Or you can put it on your calculator with your Casio, and you just put it in as you see it, 1/4 times 2/6, and the answer will still be 1/12. There are many ways to skin a cat in math, but it's subjective in terms of where to skin that cat and how you skin that cat. Okay, so that is multiplication. If you have any question, comments, query, remember, different to division and addition. Multiplication works different. What about divisions? Division. So with division, we're going to apply what I like. Those who are hungry now, please don't think about the KFC, but it must always remind you of the KFC. We call it the keep, flip, and change, which is the KFC. Keep, flip, and change. Our KFC method. So when you go and start working with divisions and all that, think about our #1 brand chicken, not the chicken licking, but the finger licking good. KFC. So but we're not going to call it the KFC. We're just going to swap the F and the C, and we're going to call it the KCF. So it means we're going to keep the first fraction. We're going to change the sign to a multiplication, and then we're going to flip the second fraction. So the numerator becomes denominator, denominator becomes the numerator. That is our KCF. Keep, change, and flip. We keep the first, we change the sign, and then we flip the second. We keep 6/4. We change the sign from a division to a multiplication because they are related, but we change the numerator and denominator. The one that was at the bottom goes to the top. The one that was at the top comes to the bottom. And then we apply the multiplication, which, remember, we can simplify. Because 7 and 14 can divide into each other, and 3 and 6 can divide into each other. You just do that. 7 goes 1 time into 7, and it goes 2 times into 14. 3 goes 1 time into 3, and it goes 2 times into 6. And we say 2 times 2 and 1 times 1. And the answer is 4, because any number to the 2/1 is the same as 2. We have an invisible 1 the same way as we have 2 to the power of 1 is the same as 2. Every time it works. We don't have to write 1 all the time. And that is KFC, which is KCF, method for division. Now let's look at this. Simplify, simplify, simplify. So I'm going to give you time because I like to give you time. And this will be our last activity for the day, because then I've run out of time. Because then we only have 8 minutes. So let me see. I'm going to go back to the chat and ask a question, because I want to see if you're still here with me. And if you haven't signed the register, please do complete the register. There is also the link to the attendance register as well as the evaluation form. So please don't forget to sign both of them. You must register and you must evaluate the session. If I sucked, tell them, oh no, this was the worst session ever. It's a waste of my time. It's up to you how you're going to evaluate. So the sessions are recorded. The recording will be shared with everyone. But before we get to that, because that will be part of my conclusion, I want to see fingers up. Do you want me to do the answers for you or give it to you as an activity? So come. The sharp means yes, give us the answer. Show us how we do it. Fingers, sharp. Okay, no fingers. No one is saying anything. It's your activity. The evaluation form is in the link. Ndima, on. Ndima, please repost it again. Some people haven't seen the chat. Okay, so are you working on it? Once you're ready, post the answer in the chat. You just need to click on the link. Okay, I see some people are asking questions about the register. The register, the links are posted. Just reposting some. I hope they work. So they will open up as a so the first link is there, the register. If you haven't completed it, it's just a form. You click on it, it will open up in the web browser and you type in your student number. That's it. I think the student number and you say which session. So remember, my name is Elizabeth Bowie. I'm not sure if it got the session name on there. I'm struggling to post the evaluation form, but the register is there, but I will get answers to my question. Answers. We have 4 minutes. None of you are giving me answers. Okay, so I can see that we got distracted with the chat. Let's answer this question. So remember, you have mixed fraction. 3 times 1 is 3 plus 1 is 4 over 3. Divide by 4 times 2 is 8 plus 1 is 9 over 4 times 3 over 16. Now remember, addition and subtraction have same priorities. Division and multiplication, same priorities. We move from left to right. So since we're moving from left to right, we can apply the KCF method. So we're going to keep the first, we're going to change the sign from a division to a multiplication, and we're going to flip the first one. And the other ones don't matter. We only flip the immediate one. If there was another division this side, then we will do the same. So because the next one is not a division, it's a multiplication, it stays as is. And voila. Then you apply your thing. Because there are 3 as well, we can simplify. It doesn't matter where you are simplifying. You can also simplify it because it's multiplication all around. So 3 and 3 can cancel out because they go into each other one time. And 4 and 16, 4 goes one time into 4 and it goes 4. 8, 12, 16, 4 times, and we are left with 1 times 4 times 1 divided by 1 times 9 times 4, which then it leaves me with 1 times 4 times 1 is 4 over 1 times 9 times 4. I think because we are close to the time, my mind needs some assistance. 36, so it's 1 time 4 times 36, yes, 36. So 4 can go into 36. Can 4 go into 36? I think so, because 4 goes 1 times into 4 and it goes 9 times into 36. 9 times 4 is 36. So the answer will be 1 over 9. That's the answer. Let's see the chat. How many of you got it right? Let's see. Let's see. Yay! I've got 2 people who got it right. Dima, I'm not sure. I can't copy and paste the evaluation form. I'm closing now. I don't know if you are able to see the evaluation form. Let me try again. See if I can post the evaluation form for you guys before you leave. I need you guys to evaluate me, because feedback is more. There we go. Hey, thank you, Irman. You were able to save us from that. And thank you, Lita. Yes. So thank you, guys. I hope you are able to evaluate me. Now, let's get, I don't have a closing slide. So since I don't have a closing slide, I'm going to use this slide. I'm going to go black screen. Thank you guys for joining today's session. It was very exciting and engaging. I do appreciate, even though we didn't talk, I was the only one talking, but you kept the live chat active, and I hope this and going forward, you will keep the spirit of the engagement, the momentum of doing all this. We have ran out of time. I'm going to share with you my email address that you can use to contact me. I know that I'm not sure if they gave me an email address that works. The slides that I've used today and the recording will be shared with you. Probably they will send you communication with regards to where to find the notes and the recording. So I'm going to leave it to the CTN TAT office. So if you also CTN TAT at unisa.ac.za. That is for the notes and recordings. Our next session is on the 29th. My email address, which I can share with you, where you can get hold of me and ask any question you want. I'm not sure which email address to give you. Yeah, I'm gonna give you my Gmail for now. I'm giving you my Gmail. It's Susake. That's an S. Ish, my handwriting is bad. That is why I like using PowerPoint slides because I know I can't write well. So that is my email. If you also want us to have a WhatsApp number or a WhatsApp contact, I don't know how to do this, but the next time we meet, I will share with you the link to the WhatsApp group. I will create the WhatsApp group and we can all join, but I'm tempted to create WhatsApp group for this group as a whole or individual modules so that you can join your actual module because sometimes the questions are relevant to that module specifically than how the sessions are working. Okay, on that note, thank you for coming and have a lovely evening. I will see you on the 29. Let me stop the recording. Okay. Also gonna put my email again on the chat in case you still have the chat active after the session. You can be able to access. Okay, so please remember to complete the register and also to complete the evaluation. Thank you very much and have a lovely evening. Goodbye. Ndima, if you're still around, please stop the recording. I'm trying to see. Hi, everyone. Unless if you have got a question. So everyone, yeah.
كويسة.
Right, so